talk to us on the first industry presentation, which is accelerating the e-mobility transformation. And the presenter is Dr. Karthik Sundarraj. May I invite Dr. Karthik Sundarraj to please come on the dais? He is a technology advisor at HMI India. HMI India stands for Hexagon Manufacturing Intelligence India, and Technical and Business Development Lead, Electronics, Life Sciences, and CFD verticals for Hexagon India and Indo-Pacific region. He is an experienced professional in simulation technology and engineering competency development across academic as well as commercial business segments. Please help me welcome Dr. Karthik Sundarraj.
Good afternoon, everyone. I think I must first of all thank all the organizers. It's a real privilege to be standing here and presenting in front of all of you. After such an interesting discussion, it's a little bit difficult for me to maintain the similar standards, but I'll definitely try to do so. So I'm Dr. Karthik. I work with Hexagon. So Hexagon is a company which is into multiple technologies, but future mobility is one of our core areas that we plan to focus on in the coming times. So I think just to set the context, like Sir mentioned, many of them mentioned, whatever may be the scenario, I think we all agree that in the next coming years, there will be a complete difference in the way cars are going to be operated as compared to today. So there is also a lot of post-COVID, pre-COVID scenarios. I think already there's a lot of production that has started. So do we have to stop? There's a lot of... Yeah, thank you. So definitely the future is that we are already catching up the post-COVID issues. A lot of production is required. We know that the manufacturing units has to be ready by now to do their production requirements. And one very important thing is EV has never gone down. Before COVID or after COVID, the requirement for EV or the need for EV has never gone down. It's only about the other automotive segments that has gone down, but they are also catching up. So what is it that we are looking at? Definitely a lot of manufacturers have already started working in India as well. We know that there is huge amount of interest. We know that a lot of companies like Volkswagen, Mercedes, they are going into complete EV as their plan. But what is the driving force? So there's a lot of driving forces here. One is, I think most of these points were already touched upon by the previous set of people. That is customer expectation. That is what a lot of focus was about. There is also range anxiety, the market jumps, the regulations, the mobility demands. There's a lot of requirement on the pollution, environment, and so on. Now, while that is also happening, a lot of companies are also facing this issue, that is, making it right is not so easy. So now everybody is in a race. They all want to manufacture and produce EVs, but there is also issue with making things right the first time, or making it right as it is being produced. So we are standing by this company as Hexagon. We know that we are working with a lot of these EV manufacturers, identify their problems and help them address those issues. So I think I don't have to dwell into what are these problems, but typical problems are around battery, thermal management, the powertrain management, and also the electronic infrastructure integration. So these are the key issues. So apart from that, of course, we would like to categorize the manufacturing challenges into four. Primarily, it is range anxiety. A lot of discussion went on. Second is the quality assurance. That is, while you're manufacturing, what is the quality assurance that you're looking at during the process of manufacturing? Third is the experience of the passenger. It's not about just making the car, it's also about the experience that the person gets. And lastly, the performance and safety. So I know that a lot of manufacturers are giving importance to all of these 4 points, but these are also the 4 points which are challenges that all these manufacturers are facing nowadays. So with that, we as a company, we wanted to build some momentum and provide some support in this. So what we are really kind of offering and providing and working with our customers is how do we really integrate design and shorten the development cycle. Okay, so this is our focus area. That is, how do you make good design and how do you kind of shorten your entire cycle. So we are taking 3 critical areas as our focus. There are many over here, but just to summarize, one is transforming e-mobility. That is, how do you make good batteries, how do you make good powertrain, good motors, and so on. The second is digital transformation. That is, how do you digitize the entire design and the manufacturing platform itself? How do you bring that on a digital forum? So that's the second area. And third is, how do we kind of transform the supply chain? So how do we help the customer on the supply chain aspect? So these are the 3 top focus areas that we as a company are taking. And we are working with people like Mahindra and Tata and so on identifying these transformations. Now, what is this transformation going to help? Like I said, it's going to reduce your time to manufacture. So there are 2 transformational changes that you can observe. One is just by digitizing your powertrain design, there is considerable reduction in your physical development time and the cost. The second is when you go to the next level, that is digitizing your factory, building your digital twin, your entire process of design, manufacturing, production, and then post-production, if you digitize that entire aspect, then there is a huge reduction in the cost of physical design. So this is the overall concept that we are working on. And how do we do that is, our Hexagon would like to basically do this, where as designed, as manufactured, and as operated should be one and the same. It should not be that you design something, you intended to come up with a product, whereas you manufactured something and then the operation itself is something else, or the use to which it is put itself is something else. So that is what we ideally would want to eliminate. So ultimately, what you design, you should be able to validate when the product is coming out of your manufacturing line, and then it should operate the way you thought while it was being designed. So what all we are doing is entirely digitizing this as a digital twin, starting from your design to engineering to prototyping, then manufacturing and maintenance, the entire portfolio getting digitized. So how do we do that? I'm just taking an example of a sample case here, motor or a powertrain. So we are first of all taking CAE-led approaches to kind of decide the material, to decide the structures, to decide the durability and the performance. There was a very interesting question from our customer. While we are designing, can we put the value of carbon that we are going to emit? When I choose a material during this process, can the system tell me how much of carbon am I going to release or use during that process itself? So that at the design phase itself, I know how much of emission that my product is going to create, and I know where I can focus to reduce that emission at the very, very early stage of design. Because while the design is done and prototyping is done, it's too difficult to go back to change your material or your product. So that's a very interesting question we are working on. So that while you choose your material, while you choose your structure, while you perform various activities at a very design phase, you are able to understand what could be the carbon footprint that you are going to create. Now, the same approach, what we do is a holistic design development for your powertrain. Okay, This again is a complete digital approach. We are always, here I'm talking about digitization of the entire process. So the first is, of course, we start at a very vehicle level, understand the highest requirement that a powertrain requires. Then we are going to a validation aspect where we build the combination of motors, the combination of different, system of systems, we say. So the idea is to build system of system. It's not about just designing the motor or the powertrain. It's about when you integrate multiple systems, how the system of system is going to react. So ideally, at a digital world, your entire system of systems should work as one individual component. And that is how you are going to understand the complete outcome of this entire portfolio of products which you put into the car. Now, one is the design, the other is can you digitize the manufacturing also? So can you really optimize the cost of stamping? Can you really optimize the cost of welding? Basically the shop floor activities, can we digitize that? So that is the second. While we do the design, we also would like to do a manufacturing process optimization. Okay, this again at a digital level. And then go to the complete holistic performance scenario. So why we are focusing on this approach is because, like I said, the digital approach gives us very good leverage in terms of understanding the outcome of a particular design product. And this certainly addresses one important requirement, that is the cost, the amount of money that is going into designing and developing new products. So what I spoke about is digitizing the design, digitizing the manufacturing, then finally digitizing the manufacturing at a subtractive level, right? So here we talk about quality. So while we are designing a product, then we are taking it for a digital manufacturing. Now you have done the manufacturing at a virtual level, you go to a production plant. That is where you need to maintain the quality aspect, where you're doing a subtractive manufacturing or an additive manufacturing, whatever may be the manufacturing approach. Ultimately, you need to ensure there is digital quality also embedded while you perform this particular activity. So what I mean by digital quality is, when you're performing your manufacturing, you are continuously monitoring a certain data. Now, these could be sensor-based data, which is constantly monitoring various parameters, and this helps in your overall modification and optimization of the entire manufacturing itself. So I'm just taking one very basic example of a hairpin. I'm not sure how many of you may be aware of hairpin, but this is a very simple but a very critical component of a powertrain. Okay, so what do we do is, this hairpin requires a lot of automated measurement. Okay, it's a very simple component, but it requires continuous optimization while the design and the manufacturing is going on. So when you perform the primary design, it is only useful for the first bending action. But after that, the next steps in that manufacturing process is purely dependent on how the optimization of that product goes through that entire scenario. So what we do is first perform a complete digital GD and T. Okay, so for this we are using certain measuring methods, certain sensory methods to perform a digital. So what we do is we create a digital design of this entire component, and then we do a on the floor shop inspection so that you are able to kind of match what you are doing. And this is so easy that it works on any manufacturing floor, and the operator of a machine can instantaneously change the action based on whatever quality and design optimization that is required. So this is instantaneous. This is happening in pretty much every action that a machine at the automation level is doing. So with that, I also, since there is MeitY, there is Niti Aayog, there are many people interested, I wanted to also say that we as a company have started working on supply build, demand and supply build. So we have a lot of customers who do not have access to skilled manpower, and EV being one of those areas which is growing. What was a request that we got from a lot of our users is to enable people so that they are employable and they are skilled enough to be employed into the company. So we, Hexagon, also have an academic initiative. One of our first initiative, you can go and check in CMTI in Bangalore, where we are setting up a demo center for what we mean by smart manufacturing. Okay, while the OEMs are all adopting new technologies, the MSMEs, the smaller SMEs also need to understand and adopt to these technologies. So that being the intention, the initiative is primarily to focus on providing these setups to academic institutions, to researchers who can use these technologies, understand it, further disseminate to the students or whoever is the employable crowd of the country. So typically, the technology should benefit not just engineers, it should also benefit the polytechnic graduates, it should also benefit the ITI. Because when a factory is set up, I think it's not only the engineers, but mostly the people who will get employed are the polytechnic and the ITI graduates at a manufacturing shop floor. So this is the intention, and we have already started working on two core areas, that is future mobility and the smart manufacturing technologies. We basically have started working with some of the governments, with institutions in providing this technology through some of our grant-based schemes. And that is also a message to some of you here. If there is an interest to collaborate with Hexagon to provide that sort of an infrastructure to your students, then we are very happy and open to do so. So with that, I thank once again to the organizers and the time given. Thank you so much.
Thank you so much, Dr. Karthik Sundarraj. To felicitate him, may I request Mr. B.D. Sharma